Hello everyone. Today I want us to see how we can construct or model this gear here, that is spare gear in Fusion 360. It's very laborious or very difficult to construct or model uh, gears in AutoCAD, but in Fusion it's very straightforward, and I wanted to see how we can construct such gears. Actually, these gears are meant for hydraulic pump. So I'm going to construct the gear using a module of 6.5. The module of gears is it is the pitch circle diameter divided by the number of teeth. Now I've got 10 teeth here. So if I divide the pitch circle of 65 by 10, I get 6.5. The next time when I come on back to this, the nomenclature of gears will be described in detail. So, like I was telling you, you see, I've got a pitch circle here, okay, which is 65, and another gear here is 65, and the pitch circles roll over each other here, and the distance between the two centers of these gears here is 65. So let's go and construct this. I'll be very quick. Now, to do the gears, you go to tools, okay, and you come to add-ins and scripts and add-ins. Click on that, scroll down to spare gears, because that is what we want to do, and click on run. Now there are metrics here for the gears. So the pressure angle, I'll leave it as it is. The module I've already told you is 6.5 for the type of gears I want to construct, and the number of teeth on the periphery of the pitch circle is 10. The backlash, I need a backlash of 1 millimeter so that the gears will not grind each other. Next time I will just describe what all these things are, and then here the root fillet radius is 0.39 times the module. So when I multiply 0.39 times the module, which is 6.5, I get 2.535. So this is what I get. Now this gear thickness, because this project is meant for, let's say, hydraulic pump, I'm going to give the thickness or the width for that to be 43, and the center diameter, I'm not going to bother about it. Here you see the pitch circle diameter has been calculated for me already. If you multiply the module by the number of teeth, you get a pitch circle diameter, which is 65 here. So I will say it's okay to go now. Click on this, and the gear is constructed here. What I'm going to do is I'm going to move this gear by a distance of 65. Why am I going to do so? I'm going to do that simply because the pitch circle diameter, the distance, I have two gears here, and the teeth mesh on the pitch circle diameter, and the distance between the two gears, if they are of the same diameter or if they are of the same pitch circle diameter, should be equal to one pitch circle diameter. That is from here to there is 65, as you can see here. So what I'm going to do here is to move this gear here by 65. I will move it back or forward, and minus 65 to move it back. So that is good for me. Now what I'm going to do is I will come back here to the add-ins and scroll down to the spare gear, and I will run this spare gear again. Actually, because I've used the dimensions for this particular gear here, the dimensions by default stays there, and I'm not going to change anything here. So I will click OK. Once I click OK, you can see that it hasn't actually meshed correctly like I want. So what I'm going to do is again rotate one of them. So I'll call the move command and I'll select this, and what I'm going to do is just to figure out which one to rotate, and I think 10 degrees is okay. I have rotated it 10 degrees and that should be okay for us. So I will say okay, and let's check it. Yes, it's cool. So we've got it nice, and this is a gear meant for a hydraulic pump that I'm designing. So guys, this is it, and thank you for watching. Expect some videos like this.